Saxon Algebra 1, Lesson 40. You guys, we're just going to go crazy with exponents in this lesson. And I'm going to start by summarizing everything that we know, and then we're going to dive into 8 problems that are just going to put us through our paces and help us practice everything that we know. Okay, we know that, let's just give it that. We know that this is the format where we present exponents. This one we call the base. This one we call the exponent or the power. You can use those words kind of interchangeably. We know that what this tells us is we multiply the base times itself that many times. So x to the 5th equals x times itself 5 times, okay? That's the basic jam of exponents. We know that we have something that we call the product rule. And that says if we're multiplying matching bases times each other and they have exponents, we can add the exponents together. We also know that if we just have a plain base, we can put a 1, an exponent of 1. Or if we have an exponent of 1, we can simplify it by dropping it off. This is what we call a definition, in that it's nothing to argue about, it just, or understand, it's just the way we use the symbols. We also know that x to the 0 power equals 1. That's just a definition, that's always true. And we also know that we've got this thing called negative reciprocals, and they're trapezes. They're not minus signs like we might find out here. We don't cover them up or take the opposite or anything like that. This is always a trapeze, and it makes us do this, right? And that's true as long as n is not 0. Right? That's just a little caveat we should put on it, because if x is 0, then it's just 1. And then we can also say, if we have a negative exponent in a denominator, we can flip it up. So the act of flipping the trapeze burns up that sign. I wish it wasn't a minus sign. I wish it was something different so that we didn't get confused with minus signs and the negative exponent. But when we do the flipping, that minus sign goes away. All gone. Okay, so this is our review of all the different rules and things we've learned about exponents. And now we're going to add one more, and I'm going to add it right here. We talked about the product rule. We're adding one now called the quotient rule. Product implies multiplying. And in this case, we were multiplying the bases together. Quotient implies division, doesn't it? And so this is the case when we are dividing, or we have a fraction, which is a form of dividing, where we have the base upstairs and downstairs, and the way we can combine that is to subtract the top number minus the bottom number. So this is our new tidbit, our new piece of exponential knowledge that we're going to tack in and practice in these 8 problems. All right, let's go. We're applying all of this. Oh, P.S. Pause me right now and copy all of this. You can make it tighter. I spread it out really big. Get all of this into your notebook. If you think you've already got it in there, just double check and make sure you can find it. If not, you might want to just write it all together so it's right where you want it whenever you need it. Everything's together. Okay, pause me, come back when you're done. All right, welcome back. While you were gone, I flipped over my book and I wrote example 40.1. All right. Our instructions are to simplify and to write the answer with x in the numerator. All right. And we see that what John is doing is he's putting that quotient rule right to work. Remember that, I'm going to write it again. If we have matching bases above and below, we can subtract upper minus lower. So this will be x 6 minus 4, right? Okay, so that is a really great way to combine that. All right, now, some people see it like this. They take the x to the 6 and they kind of mentally, they take the x to the 6 and they spread it out like this, which is fine, you can do that. Then they can see, oh wait, it's 4 on the bottom, sorry. Then they can see, oh, the x to the 4th and the x to the 4th cancel, and I'm left with x squared. That's another way of seeing the very same thing that we did here. It all works for the very same reason. Simplify. Write the answer with x in the denominator. Oh, okay. It's the same problem. We're going to approach it just like we did last time, using the product rule for exponents. You guys have to know I'm obsessed with these rules for exponents. They are so helpful. Okay, so we do that and we get x squared, but this time we're supposed to write the answer with x in the denominator. So we're gonna need a trapeze to flip it down, right? So we're gonna change that into 1 over x to the minus 2. By adding that minus sign there, we're saying that what we really need to do is flip it up. But this is the answer John wants because he wanted that answer with x in the denominator. So this is the right answer for this problem. So moral of the story, he's going to now start telling us what form he wants the answer in. Sometimes he will, not always. But in these problems, it's fair for him to say so. And we have to learn how to use negative exponents to flip things around to take the shape he wants. 40.3, simplify x to the 6th over x to the minus 4. Okay, here's where we need to be careful. Remember, our formula tells us that it's the top number minus the bottom number. Ooh, so we have double minuses. Be careful. Okay, whenever you're using the quotient rule, be careful. Any formula that has a minus sign in it is just a landmine waiting to happen. A minefield, a landmine. No, it's a landmine. Okay, so this would be then x to the 10th, because that becomes a plus. Cool? 40.4. Simplify. John's getting abstract on us now. This problem does not have numbers in the exponents. It just has letters. But guess what? We don't care. We're going to follow the same rules and use our quotient rule. X to the variable or exponent on the top minus a minus variable on the bottom, b. That's it. That's all we can do. But that's an answer. That makes John happy, so you know. It's good for us. I'm just looking to see if he said anything. He does not care if we write that in the numerator or the denominator, but let's just say this is in the numerator, obviously. Let's just say he wanted us to write it in the denominator, the variables in the denominator. That means we have to take whatever we had up here and we have to put a negative in front of it. So now it gets weird because this a goes to positive and this b goes to positive. Strange, right? But this would be another way of formatting the same answer. Equivalent expressions, you might say. Okay, one more of these, and then we're gonna put another twist on it. Don't you love it? John always has a twist for us. It's what makes math exciting. And this is just such a fabulous, time watching these videos and just, I'm sure you're on the edge of your seat trying to figure out what is John gonna do next and how cool is it gonna be? All right, simplify our instructions. X, oh, here I am saying it again, just copy. You guys are writing all this down, right? Make sure you do. Okay, so what we have here is a big mess compared to what we've been doing. This is considered a rational expression because it's got a fraction. It's a fraction, it's top and bottom. All these dudes are being multiplied together. All these dudes are being multiplied together. And while we see that there's no repetition of the bases in the top or in the bottom, they do repeat this way, right? So that tells us we can use the quotient rule, which again means, oops, m minus n, that's an x. I got excited to talk about the exponents. So what we're gonna do is we're gonna break it down for each one of these bases and we're gonna calculate the combined exponent. So I'm gonna write that over here. For x, now I'm just gonna write the exponents here. We have minus 5 minus nothing on there. Oh, so we can put a 1. So minus 5 minus 1 would be minus 6, wouldn't it? All right, so our answer is going to be x to the minus 6. We know that much. Now let's do the y. Notice I'm going in alphabetical order. Y is 6 on the top minus 2 on the bottom. That's 4. So our final answer is y to the 4th. And then our z calculation, Jonathan Bragg, z's, I think we talked about that last time. Z is, okay, nothing here, so let's put a 1 in. 1 minus for the formula, and then minus 3. So that becomes a plus, so that's also 4. So there's how we calculated the exponents that go on each of the different bases for our answer. Now, John wants to point out that this is correct, but there are 4 different ways that we could write this answer. One is with everything, all bases, or variables, we might say, either way, in the numerator. Right? We wrote everything in the top. Now let's try writing it with all, I'm just going to say variables, in the denominator. Whoops. Okay, and we know that the way to do that, x to the n equals 1 over x to the minus n. So we know that if we put a minus sign in front of the exponent in the numerator, that will flip it down. So let's figure this out. This will be 1 over, okay, this will be then x to the positive 6, right? Because we're just changing the signs on everybody. Here, we need some puffy clouds of knowledge. Whoa, that one hit a skyscraper. Okay, so we're using this. We're changing the sign to move it to the denominator. So y becomes minus 4 and z becomes minus 4. All right, so that is another option. That's correct. Now what we want to do is say all exponents positive, okay, and so we get back to our original. We see these guys are already positive. In order to have this be positive, we need to kick him downstairs. So we're going to keep it y to the 4th, z to the 4th upstairs, and then x we're sending down so that he'll go positive. So there is the way we can write all the exponents positive, and then our last one is all exponents negative. Going back to our original, here, let me do this, just to kind of create a little more organization to our answer. My lines are a little wobbly, but putting these guys in boxes helps us keep it all straight. Okay, all exponents negative. Again, we go back to our original calculation. We see, okay, x is fine because he's negative. These guys, we're going to boot them downstairs, again, using this rule. So it will be x to the minus 6 up top, and then y to the minus 4th, z to the minus 4th. That looks a little big, but that's the exponent, that's the base. Okay? So when we create these answers, we can present them in any one of 4 ways. John will tell you how he wants it. And if he doesn't tell you, you can do it however you like. Just know that when you see John's answer in the solutions manual, you may have to do a little adjusting to get from his answer to your answer. I prefer this one unless someone tells you differently. So my sort of go-to format is this format. But of course, if John asks for something else, then we can play it the way, whatever John wants to do. He, you know, he's holding the cards here. Okay, example 40.6. Now what we're going to do is, instead of just having fractions to simplify, we're going to use the distributive property, multiply first, and then simplify. These problems get a little crazy. There's a lot to them, and copying them is a must, you guys. Please don't try and skip that. Y to the, that's a 4. I don't usually write my 4s that way, but I just couldn't help myself. Okay, we see a lot of x's, we see a lot of y's, we see a lot of positive and negative exponents. There's a lot of 2's and 4's flying around. I'm just going to look at it again to make sure I copied it right. Yes. Okay, the first thing I see I don't like is a floater right here. Put him in the fraction club. Okay, now we remember how to distribute fractions. We do the numerators, and then we do the denomies, right? Okay, I am going to do a lot of this work without these calculations. I'm going to talk you through them. If it gets confusing, you have to tell me. All right, so I'm going to start here, and I'm going to multiply by this one. I see just the number 4. I see x to the minus 2 and x to the positive 2. That becomes x to the 0. X to the 0 equals 1, so I can just cross it off. And then y to the 4th stays the same. Now I'm going to do the denominator of the first one. Y to the 4th times 1 is just y to the 4th. Now we minus, subtract. 4 times 3 is 12. And we've got x's here. I add the bases. Minus 2 plus 4 is positive 2. And now here's a y on the bottom, and I add the bases, right? Because I'm multiplying here. I'm using the product rule, so I just add them, and that becomes 2. Now I go through one more time and look to see if there's anything I can simplify top to bottom within each fraction. And I see, oh yeah, look, y4, it would be 4 minus 4 is 0, so that's y to the 0. That goes away too. This one looks done. So my final answer is 4 minus 12x squared over y squared. And John asks us to write the answer with all exponents positive, and everything looks really good in my answer, so we don't have to change anything. Yay. 40.7. And these go up through 8, so we're almost done. Use the distributive property to expand. Write the answer with all the variables in the numerator, all right? That's one of those things, by the time I get to the end of the problem, I don't remember what John told us at the beginning, so I always look back. And that's a really important thing to train yourself on, you guys, is always look back at the problem and make sure you answered the question. In upper level math, that becomes such a thing. Okay, x to the minus 2y. Oops, I'm doing that out loud thing again. Just copy. All right. Looking for floaters. Look, the one on the outside needs some help. I like to always draw these. It just helps me make sure I do all 4 steps and don't rush through it. Okay. First I'm multiplying. I'm looking for matching bases. I add their exponents. I see a y and a y. This guy doesn't have an exponent, so I go ahead and fill it in because we know that x equals x to the first. You can write it either way. All right, so, and that goes for y's too, right? So this becomes x squared y to the 5th, and then the bottom is x squared. Oh, I can see that's going to cancel, but I'm going to leave that for the second step. And then we're subtracting, right? Now we go this way, it would be x to the 6th, we add those, y over y squared. Okay, this cancels. I'm left with just y to the 5th here. Now I can subtract here, right? This would be, there's a 1 up top, so this would be 1 minus 2, and so that equals a minus 1, right? So I'm going to just put a minus there and cross that out. My y exponent on top was a 1, my exponent on the bottom was a 2. I subtract top minus bottom. That gives me a minus 1. So I just rewrote it using that one. I just put a minus sign, but I crossed that out. Those we canceled. So now I've got my answer. It's this much, right? I've crossed out all of these things. Let's just check again. Write the answer with all variables in the numerator. Oh. We worked the problem right, but I copied it wrong. So there's a little drama there, but we're not going to worry about that. This is perfectly fine. So our final answer is y to the 5th minus x to the 6th. And because John wants all the variables in the numerator, that means we leave it as a negative. So that is our final answer. And if you go and look at example 40.7 in the book, it's slightly different, but ours was just as challenging and we got it right, so it's fine. No drama. Last one, ready? Example 40.8. Use distributive property to expand. Write the answer with all the variables in the denominator. So we're sending everybody down when we're done. This one's got a lot of different letters. And I'm going to carefully double check to make sure I don't make any mistakes in it again. Okay. If you would like, work this one yourself. I will work it without talking so that you're not disturbed. And then after I finish, I'll wait for a minute or two. Well, not that long, but I'll give you a little bit of time to catch up and to check your answer against mine, all right? One thing I'm going to say is because I have a fair number of different variables, I'm going to go alphabetical in this one to keep myself on track. Okay, if you need more time, feel free to pause, but I'll go ahead. This is what I got. There's the A, the B's cancel each other because they add up to 0, K squared, and then we have the number, and then there's alphabetical order of everything else. Now I'm gonna go through again and look for anything that I can combine. Only the 1A. K's will cancel, won't they? Because using the quotient rule, it would be 2 minus 2, that's 0. I can also look at it as anytime you have the same on the top and same on the bottom, you can cancel them. So that goes away, and here's what I have left in the first fraction. Now let's try this one. Again, the B's cancel, it's 1 minus 1, or again, you can just think, anytime you have the same thing top and bottom, you can cancel. The K's are by themselves, but the P's here we can figure out. The P's, it's 2 minus the one in the bottom minus 2. So that's going to be P to the 4th. So I'm going to cross this out and change that 2 into a 4. Right? And there's how I figured that out. So up on top, I have this and this and this. Now, John's instructions say, okay, so make sure you have this much with me. A over P to the minus 2 minus 4K squared, P squared. Now, John wants us to write the answer with all variables in the denominator. This was a little trap I fell into. Variables, that means letters, not numbers. So that means we want all the numbers to go downstairs, but we want the letters, we want the letters to go downstairs, but the numbers, like that 4, stay up top. So let's look at how that works. Letters go down, that means we need to put a 1 to hold the top of this fraction. This is a to the 1st, so it will be a to the minus 1, right? Because to get it to go downstairs, we put a minus sign in front of it. So there's a minus 1, and that's all we have in the top, and the P is already negative, okay? So that's our first term. We're still subtracting it. Now, we want to leave the 4 up top because we're sending the variables to the denominator. And that means K will get a minus in front of the 2, and P will get a minus in front of the 4. And that is, yeah, I'm just checking my answer against John's. Yep, he has those in a different order, but that's okay. Order doesn't matter when you're multiplying. So this is our correct answer. You guys, we just crossed the threshold from easy Algebra 1 to some fairly complicated stuff. So be proud of yourself. It's getting harder, and I hope you can feel it getting harder. But these are some fairly complicated calculations. You need to work neatly. Give yourself plenty of white space so you can see what you're doing. Make sure your exponents are big enough when you write them that you're not looking at some tiny little brain-piercing squiggle. Read the instructions carefully to see how John wants you to format your answer. Here's where we reviewed. This is the rule you use to flip things up and down. This is where we reviewed what each one means. Good luck. I will not talk to you the week that you're doing this, but the next time we have a video chat, I want to talk to you about these and see if your brains have turned to figgy pudding just yet. All right, great job. I will see you on Monday after Thanksgiving for lesson 41. Farewell.